In this example, we're going to solve this linear system by elimination. So the first thing to do is make sure that the equations in the system are written in standard form. So that is x, y equals a number. Well, it appears like the first equation is, but the second equation is not. So this one is x equals, and then it looks like our y term is over here on the right side with our constant. So in order to write this one in standard form, I'm going to go ahead and subtract the 4y, bring it over to the left. So I have negative 5x minus 4y equals negative 1. I'm going to go ahead and rewrite this first equation right underneath it. Okay, so here I have the two equations. Both of them are in standard form. And again, we did that so I would have like terms aligned vertically. So the x's are on top of one another, the y's are on top of one another, and the constants are over here on the right side. So the process of elimination is going to combine the two equations in the system by addition, and in doing so we're going to create a single equation with only a single variable, which then we can solve. Because right now I have two equations with two unknowns. But remember, in order for elimination to be effective, the coefficients of whatever variable we choose to eliminate have to be equal in number but opposite in sign. So of course when we add numbers that are like that, they cancel out. So if I were to look at my y's, I would notice while they are opposite in sign, they're not equal in number. One's a 4 and one's a 3. So these would not cancel when I added them together. But my x's, negative 5 and positive 5, they're both 5 and they are opposite in sign. So I could add up my x's and those would cancel out. So let's go ahead and take these two equations just the way they are, and let's go ahead and add them up. So negative 5x plus 5x, my x's cancel. Negative 4y plus 3y will be a negative y, and negative 1 minus 3 is negative 4. So when I divide both sides by negative 1, y equals positive 4. So I'm going to take that positive 4 and I'm going to dump him back up here into one of these original equations. Let's go ahead and plug into this second one because the x is almost by itself already. So negative 5x equals 4 times y, and y is 4, and then minus 1. So negative 5x equals 16 minus 1, which becomes 15. So when I divide both sides by negative 5, x equals negative 3. So now I have determined the values for each of my variables, x and y. So I'm going to write them as an ordered pair, negative 3, 4. And this ordered pair functions as the solution for this linear system.